Hey guys, welcome to my channel. My name is Lokesh and I work as a lead architect in one of the data and analytics companies, not only analytics data as well as the AI company. So today, we'll continue our book reading series and just to remind and recap, we are going through a book called AI Engineering, which is written by Chip Huang, and this book has got a lot of traction. A lot of people, especially on LinkedIn, are recommending this book. So I have read parts of it, and it was able to give a lot of clarity to me in terms of various topics involved. So which is a good thing. And remember, guys, we are not going to cover all the chapter. We are just touching chapter 10, which is the last chapter in this book, because again, we want uh, not to have any copyright claims on our channel, but if the author suggests that we should take this video, we'll do that. But what would happen for me personally is I would have gained some information out of it, and I hope if you watch this video you also gain some information. The idea here is, guys, see, I'm not an expert in AI by any means. I have said in my past videos as well, and just want to reiterate that by doing this, I'm developing a habit of learning some of the concepts in Gen AI. Otherwise, I would not do it if there is no habit or ritual behind it. So, and I would, for the same reason, I would encourage you to, participate, ask questions, go through this, learn with me. And if you have, any suggestions, put that in the comments box below. So, with that said, let's look into this. So, we are going through chapter 10 called AI Engineering Architecture. So, here, the author gave us the vanilla version of the architecture where you would only have user input and output if you see here. Then the author introduced the context construction, which is very vital if we want to, get or read the data from our internal databases, or you know, you want to, in any case, you want to add, more context to the prompt that you're typing so that we are able to get the right answer. And then in step three, we saw in the last video, especially the concept called guardrail implementation. So there could be two types of guardrails: input guardrails, output guardrails. And the input guardrails are where you don't want to send out the personal information, PII information, and the output guardrails is where you would want the answers to not to have any profanity, not to have any biases. Biases could be there, but as far as possible, try to remove those biases, not to have any, controversial answers. So that is where your output guardrails comes into picture. And not only that, in some cases, you might get, a false answer. You might not get an answer. So that is why you will have the output guardrails in place. So we'll continue our reading, and we will now look into step three. So I would have thought we would look into step four, put in guard. So what was the step one? Okay, so step one was to enhance context. So you had the vanilla architecture or the basic architecture, and then you have enhancing the context, and then you have put in guardrails. So now we go into step three, which is add model, router, and gateway. So let's read through. As applications grow to involve more models, routers, and gateways emerge to help you manage the complexity and cost of serving multiple models. Router, instead of using one model for all queries, you can have different solutions for different types of queries. This approach has several benefits. First, it allows specialized models which can potentially perform better than a general purpose model for specific queries. For example, you can have one model specialized in technical troubleshooting and other specialized in billing. Second, this can help you save costs. Instead of using one expensive model for all your queries, you can route simpler queries to cheaper models. So, what is being discussed here is that Instead of using a single model, let's say ChatGPT 4 or 4 or whatever it is, you should design your application so that you are calling multiple models. Why you want to do that? Because certain models would be cheaper. The token burning rate, or no, if you call the API, the token burning rate would be cheaper as compared to some of the foundational models. So that makes sense. Let's continue. A router typically consists of an intent classifier that predicts whether the user is trying what the user is trying to do. Okay, based on the predicted intent, the query is routed to the appropriate solution. As an example, consider following intentions relevant to a customer support chatbot. If the user wants to reset the password, route them to okay. If the user is corrected billing mistake, route it to human operator. Okay. If the requester is about troubleshooting a technical issue, route to chatbot specialist in troubleshooting. Makes sense. An intent classifier can prevent your system from engaging in out-of-scope conversations. If the query is deemed inappropriate, the chatbot can politely decline to respond using one of the stock responses without wasting an API call. For example, if the user asks who you would vote for in the upcoming election, a chatbot can respond with, as a chatbot, I don't have the ability to vote. If you have questions about our products, I'll be happy to help. So this would be, very useful, especially in the applications which are available to the wider audience. If you have a Gen AI application which is within your organization, people might not ask these questions because they would understand that they would have to be professional, and they cannot out ask or they should not rather ask outside of that purview. If they do that, that could again subject to some of the policies that the company would have, or if you have the intent classifier implemented, you'll not get an answer. So this would become more, useful for the general public because you will have a number of questions on your mind, and some of these questions, you might want to ask just for the sake of asking, just to see, what response you're getting. We all have done that. I'm not denying that I have not done it. I think you might also have done it. But the thing is, if you have intent classifier, these questions could be skipped, in the sense that when you ask these questions, when you ask these prompts, the Gen AI application would not make a call to the API. Instead, it will return you some boilerplate stuff stating that you cannot ask, or the chatbot, or the uh, the response will be something like that I don't have access to such information, so which is good to have. An intent classifier can help the system detect ambiguous queries and ask for clarification. For example, in response to the query freezing, the system might ask, do you want to freeze your account, or are you talking about the weather? Okay, that also makes sense. Ambiguous questions. Other routers can aid the model in deciding what to do next. For example, if for an agent capable of multiple actions, a router can take the form of a next action predictor, whether the model use a code interpreter or a search API next. For a model with a memory system, a router can predict which part of the memory hierarchy the model should pull information from. Imagine that a user attaches a document that mentions Melbourne to the current column. Later on, the user asks what's the cutest animal, and the model needs to decide whether to rely on the information in the attached document or to search the internet for this query. Okay, so routers can not only use to classify the type of questions that is being asked, it also can aid in maybe planning the action. So, for example, if you have asked a question, the router can ask multiple questions just to get complete understanding and be absolutely sure that this is what you wanted to ask, and this is the information that you wanted to get. And then they have the author has given the example of the memory system, especially if you have a document that has certain information, and if you ask a question on top of it, then the router might help decide whether that question should be answered from the document itself, which has been attached, or it has to go to the internet to get that information, which is also good. Intent classifiers and next action predictors can be implemented on top of foundational models. Small teams adapt smaller language models like ChatGPT-2, BERT, and Llama 7B as their intent classifiers. Many teams opt to train even smaller classifiers from scratch. Routers should be fast and cheap so that they can use multiples of them without incurring significant extra latency and cost. So the interesting thing here is even your routers like intent classifiers and next action predictors, these would also be Gen AI or AI based, and you would need models for these as well to get these tasks done as well. So what the author is suggesting that companies which do not have many funds, they can uh, use cheaper models like GPT-2, BERT, and Llama 7B as their intent classifiers, whereas the others where the intent classification and next action predictor is also very crucial. For example, the companies which or those companies which have funds, they can may probably think of designing a new model in itself by training the model. So that is important point. When routing queries to models with varying context limits, the query's context might need to be adjusted accordingly. Consider a 1,000 token query that is slated for a model with a 4K context limit. The system takes an action, example, a web search. Okay, you can either truncate the query's context to fit the originally intended model or route the query to a model with a larger context limit. Okay, let me just read this again. I think I understood, but I just need to focus again. When routing queries to models with varying context limits, the query's context might need to be adjusted accordingly. Okay, consider a 1,000 token query that is slated for a model with a 4K context limit. The system then takes an action, example a web search that brings back 8,000 context. You can either truncate the queries. So here there are some important things. So one is the input token limit, which is 1,000, that is slated for a model with a 4K context limit. Okay, the system then takes an action, web search that brings back 8,000 token context. You can either truncate the query's context to fit the originally intended model or route the query to a model with a larger context limit. So we are just talking about the input uh, token limit only, I think. So what the author is saying is that if you have a 1,000 token query that is slated for a model, so you have a 1,000 token query, and the limit is 4K. But if that query in turn refers web and brings in more context, now the context becomes 8,000 token long. So obviously, which is this would be greater than 4K. So in this case, the answer would have to be, or the context would have to be truncated. So let me just Gemini this one. I think the input context limit is being talked about here, but let me just Gemini this one. So let me just ask the question, is the author talking about input text limit, the below paragraph. Yes, the author is talking about here's why context limit. The paragraph explicitly mentions yeah, for the maximum amount of information. The discussion about truncating the queries, token count they mention the importance of context limits. Yeah, this is the input context limit. There could be an output context, or there should be an output context limiter that would not come as context, maybe output response limit. So that is also one of the important things. Because routing is usually done by models, I put routing inside the model API box. Like scorers, routings are typically smaller than models used for generation. Grouping routers together with other models makes model easier to manage. However, it's important to note that routing often happens before retrieval. For example, before retrieval, a router can help determine if a query is in scope and if yes, it needs retrieval. Routing can happen after retrieval too, such as determining if the query should be routed to a human operator. Routing retrieval generation scoring is a much more common AI application pattern. Routing retrieval generation. Okay, but is the retrieval this retrieval is mostly for RAG applications or for others as well? So just to make you understand what I am thinking. So the author is saying that routing should be before retrieval. Now retrieval is only there for RAG systems, or maybe retrieval is there for other, context construction systems where you are trying to get the data from some APIs. So that thing is not clear to me. So let me just type in here in the below paragraph. Does retrieval applicable only RAG systems? You're right to question that. The paragraph does seem to imply that retrieval is a core part of the process, but it's not. Retrieval is common but not in the paragraph image. Retrieval depends on retrieval is essential when the model needs external information. This is the core idea behind. However, for tasks where the model can solely retrieval might not, for example, routing can still be useful without even. While retrieval is a crucial part of many APIs, particularly those, it's not a universal requirement. Routing can function independently. So that's still not clear. So maybe it's safer to assume that this could be for RAG applications or non-RAG applications routing. So routing should happen before retrieval. But then the author also says that it could happen in some exceptions where routing is done after retrieval. That's okay. So now we look into the gateway. A model gateway is an intermediate layer that allows your organizations to interface with different models in a unified and secured manner. The most basic functionality of a model gateway is to provide a unified interface to different models, including self-hosted models and models behind commercial APIs. A model gateway makes it easier to maintain your code. If a model API changes, you only need to update the gateway instead of updating all applications that depend on the API. Shows a high-level visualization of a model gateway chatbot support. Okay, so think of it as API gateway. So whenever you're making calls to the models, there should be one centralized place through which these calls should be made. And the fact that authors suggest that in case of any changes, you might want to just change the gateway mean that this gateway would contain the configuration of these APIs. So if the API has to be changed, it has to be changed in the model gateway. You wouldn't have to go anywhere else. In simplest form, a model gateway is unified wrapper. The following code example shows you an idea of how a model gateway might be implemented. It's not meant to be functional as it doesn't contain any error checking for optimization. OpenAI model, Gemini model, model type. This is the model gateway. So this is an application that has to be built. So what is being done here is you have two functions. One is calling the OpenAI model, the other is calling the Gemini model. You have the key over there, and then you have the key in both the places because the API key should be required. And then you have model gateway. So this is a function. So if the request is coming from OpenAI, it will call the OpenAI model. If it is coming from Gemini, it will call the Gemini model. A model gateway provides access control and cost management instead of giving everyone who wants access to the OpenAI, which can be easily leaked. You give people access only to the model gateway, creating a centralized control point of access. The gateway can also implement fine-grained access control specifying which user application would have access to which model. Moreover, the gateway can monitor and limit the usage of API calls, preventing abuse and managing costs effectively. A model gateway can also be used to implement fallback policies to overcome rate limits or API failures. When the primary API is enabled, the gateway can routes requests to alternative models, retry for a shorter while, or handle failures gracefully in other ways. So model gateway not only is provides a single place where you define the calling of your models, but it could also help you in securing the model access or maybe providing a fine grain access to your models. Fine grain means access to certain models to certain people or a group of people, and then it can also help in case of any failures or if the response time from the API is taking long. I think it can also help. Given that gateways are relatively straightforward to implement, there are many of the off-the-shelf gateways. So these are some of the gateways. In our architecture, gateway now replaces the model API box as shown in figure. Okay. So inside model gateway, you have routing generation and scoring. Cool then. So I think we will stop our reading session now. And yeah, I think I gained quite a bit of knowledge, especially around routing and model gateway. So we'll continue this chapter 10 book reading series of AI engineering book. I hope you gained something out of this video. So we'll meet soon in the next video. Till then, take good care of yourself. Bye guys, and don't forget to subscribe.